But we're headed back to Hamburg now, and oh, okay, I think we're back here now.
Okay. Welcome back to Hamburg. My name is Thomas Graupe, and I'm here in the Planetarium in the Sky Theater. Behind me you see the star ball rotating. That's what what Armand and other planetariums used to have, but now times are changing. You see, the planetarium is a big machine. A model of the universe, and that's being used, this star ball, maybe the camera can show the projector a little more. It was a representation, a model of our universe. It represents the naked eye view of the universe based on the observer's location on planet Earth, looking with the naked eye without a telescope to the sky. That's what this machine can do, the star ball and the planets. But since the invention of the planetarium, astronomy has changed a lot, and the telescopes have had a dramatic evolution. We now no longer astronomers look at the sky even through a telescope. They send their commands to servers around the world, gathering data of the universe, and receive the data through the networks. Like we talk now through the networks, they receive data through the networks. So in a sense, there are giant data archives of observations, and we can dive through those data, virtual three-dimensional data of the universe, which we can display on this big dome here, on the Planetarium dome. And behind me and surrounding us is an image of the universe. And let's just dive into the database. We are connected here in the Planetarium with the servers around the world. This is based on work that has been done, sponsored and supported by NASA at the American Museum of Natural History. This was the start of this digital universe project, which is now the core of many digital full-dome planetariums, and they can show you the universe as it really is right now, a three-dimensional tour of the universe. And I'm now using this Xbox and flying you through the universe. I'm going back to the console and do this for you and dive through the data sets, using them as a sort of a virtual observatory. So you see the Earth already here, and okay, I take a seat here, a driver's seat, and okay, we leave planet Earth. Where here you see Europe here, and we fly out and rotate around. I'm doing this real time, and we see the Earth getting smaller and smaller. That's nothing new to us. Many software packages can do that, but remember, we are connected to servers and to data sets on servers. This is happening now here in real time, what I'm doing. And you see the sun, our solar system, certainly our home is here circling as the third planet around the sun. You see, what we see is data sets, certainly the positions of the planet. That's classical astronomy. But let's go out, further out here. So the key question is no longer where on Earth we are. The key question is where are we in space and time? And we witness now this digital model, this digital representation of our universe. We leave the Earth and leave the solar system, and let's have a look at data when we leave the Kuiper belt, the range of comets, and the Oort cloud here behind us. We can look at other solar systems. If we load in the data of other planets screen, and I can fly those markings and the descriptions. You see Gliese, you see Epsilon Eridani and other planets here as these markers mark the stars around which we have found planets. And so the data are in the archives, and we can display them and look at their distribution. And as you see, they seem to all seem to be surrounding our position in the universe. And that's because we have this bias in the data. We observe, we not only observe, we have to interpret every observation. So the telescope is one step there. The model we use, the grid in which we place the data, is the other thing. So we leave our galaxy and we see there is, well, certainly we saw only planets surrounding the sun because we can only see so far with our detection mechanism. Now we leave our galaxy and we see the spiral arm in the center of the image where our home is, and this tiny speck surrounding the sun where we can see stars with the naked eye. But that's the model of our galaxy, and it's a spiral galaxy. You see, it's if I move around, we see the edge-on view here, and you see the dots coming into view. Those are the Tully galaxies. Brent Tully's galaxy catalog has about 30,000 galaxies, and we show those data here. And well, they're different colors. They're meaning they are part of different groups of galaxies. I don't want to go into details here, but each dot is another galaxy. And let's move further out, and you see, but we can enlarge those galaxies, put in a model of each galaxy. What type of galaxies are we observing? And you see now, okay, the most of them are surprisingly spiral galaxy like our own, but that's just an observational bias because we don't see the smaller, less luminous, irregular galaxies which we only see in our surroundings. So you see, this is the ocean of galaxies. That's just the foam in the cosmic ocean. Between those galaxies, there is also something we don't yet know. But you see, I'm flying real-time through the data sets, and let's turn off the galaxies. We enlarge them to make them visible, to see the structure of those galaxies. Okay, but now you see the distribution of those galaxies. Certainly, this is just a cube of galaxies surrounding our position in the universe. It's 300 million light years each side of the cube you see rotating in front of you. 300 million light years and 30,000 galaxies. But that's not all there is. There are other surveys collecting data, and let's go out, further out, with a survey done by load-in data from the 2DF survey, 2-degree field galaxy survey done at the Anglo-Australian telescope. You see fans of galaxies, like fanning out to the North Pole, that's up here in this image, and to the South Pole, and some single beams of fans of smaller galaxies, of smaller areas alongside the lower fan. Those are point of interest observation. But you see, those are observation 2 degrees fields probing into deep space here, and we see the structure, the distribution of, you won't believe it, 230,000 galaxies. Each dot has a name tag on it, has a distance, and so we can, or at least a number in the catalog. So you see in the center the cube of Tully galaxies, and then we look deeper in the universe. And we can go even deeper than that. If we add in the same survey 2-degree field of view, well, I went too far too quick. We see the quasars.